How do we deal with changes in demand, and what does it have to do with elephants? In the last video, we saw there were different approaches to determine peak flow and that the most powerful one is time-varying demands. We start with the daily variations. They reflect the changes in water use as people go about their day. In my mind, they tend to look like elephants, with a big round peak in the morning, a midday plateau, and a smaller peak in the afternoon. Nighttime consumptions are usually low and can be a very good indicator of leaks. In the diagram, the orange line represents the average flow of the system. At any given time, say 3:30, we can obtain the instant flow by multiplying the average flow by the peak factor, in this case 0.2. The peak flow factor, 1.75, will be the daily coefficient. You would proceed the same way for any other point. The daily coefficient represents the busiest time of the day and will be used to determine pipe size. The set of all peak factors is called the daily pattern, and besides things like water aging or chlorine levels, it is used to size tanks. The pink line represents how water is being produced. If water is consumed as it is produced, there's no need for storage. The more difference between when the water is being used and when it's being consumed, the bigger the tank. But this daily peak factor is not the only one at play. There are also variations between the days of the week, with weekends usually having lower consumptions. These variations are taken into account with a weekly coefficient. Finally, there will be a seasonal pattern with more consumption in the summer months and less throughout the winter. In many contexts, you end up with a chicken and egg problem. There's no functional water system nearby to measure from. In these cases, a good estimate is to take a global coefficient between 3.5 and 4.5. Once you have all the coefficients, you can assume 20% of leaks, or 1.2, and multiply all of them together to come up with a global coefficient. If you're using a computer program, the daily coefficient together with the rest of the peak factors will go in the daily pattern, and the average flow multiplied by the remaining 3 are distributed among the system's nodes. Take this network, for example. The peak factors have been introduced in the daily pattern that includes the peak coefficient of 1.78. Then, each node has a base demand that includes all the other ones. As the model runs, the program multiplies the base demand by the peak factor of each hour, showing the difference in pressure for each one of them.